Okay, we are now recording, screen is shared. Okay, semua ready? Hari ini kita akan sambung our lesson. Kita akan habiskan just a little bit lagi of chapter 1 and then kita akan discuss. I forgot to share tutorial number 1 but it's okay. Kita akan discuss hari ini the questions and then kamu akan proceed to jawab jugalah. Okay? So kamu boleh jawab with the with discussing the questions beforehand. So please make sure everyone submit the tutorial number 1. Saya baru post pagi tadi. Link ada dalam Google Classroom. Okay, sekejap. Afzan Najwa waiting in the lobby. Welcome. Okay, all right. So just a refresher. This is instrumentation analysis. This module is about exposing students to the pharmaceutical manufacturing and analytical pharmaceutical manufacturing and analyzing industry. Okay, so kita nak discuss dalam this module kita terapkan a couple of chapters about the manufacturing and the analysis of pharmaceutical drugs. Kita go through in our first class hari itu about the workflow of how this process works. It starts from a supplier. Bermula daripada supplier akan hantar barang yang kita order. Okay, kalau nak buat ubat, kamu kena ada ingredients ya. Active ingredient, dia punya bonding agent, coating agent, coagulation agent, all those stuff akan diorder daripada supplier. Supplier akan hantar and barang-barang ini akan diterima oleh warehouse. Warehouse akan store and dia akan sample out bagi pada production department untuk buat ubat, untuk formulate ubat. Bila production department dah buat ubat, dia akan hantar a few samples kepada QC lab, quality control lab, for QC testing lah, quality control testing. So bila quality control testing dah habis buat all the required tests, semuanya pass, dia akan send a report to QA. QA akan review. If everything is okay, if everything is according to protocol, dia akan approve the batch of the drug untuk market. Kalau ada problem with the testing, investigation needs to be made. Maybe kena halt the production of the drug, of the batch. They kena investigate what is the problem, kenapa ubat tu fail the test, and then kena fix the problem. If the problem is fixed, baru boleh proceed with release. Kalau the problem is not fixed, you kena scrap the whole batch. Maksudnya kena reject lah, buang and dispose. Okay, so that is basically the workflow. And also hari itu kita dah discuss about accuracy, the difference between accuracy and precision, how to identify the pattern of error based on understanding the of accuracy and precision. Okay, so today kita nak sambung about that accuracy and precision tu by relating to this. If you look at the screen, saya tunjuk the slide of what is quality control. Okay, kat sini the first slide of QC, it is a method to control error in analysis. Macam saya cerita, so saya cerita last week, first class, kalau kita nak perform test, usually kita akan prepare duplicate solutions. Banyaklah contohan saya ni. Never mind. Okay, selalunya kita akan prepare duplicates. So nak cari. Okay, dah jumpa dah. Let me. Okay, so kalau kita nak buat test, kita nak perform any test, we need to prepare at least 2 types of solutions. Kita ada the sample solution dan kita ada our standard solution. These are the 2 types of solution. Standard solution ni yang mengandungi just the API, the active ingredient. The sample is our tablets lah, for our drug. And for the standard solution, usually kita akan prepare 2 duplicate. Okay, standard number 1 and standard number 2. For our solution, kita akan prepare 6 duplicates. So the reason why we prepare duplicate solutions is for us to be able to observe our accuracy and our precision. Sebab kalau ada any deviation from the results of these duplicate solutions, kita boleh nampaklah the pattern of error dekat mana kita buat. Maybe kita buat an error in measurement somewhere in the preparation, so the reading of the final result maybe tak sama. Sepatutnya kalau all of these samples are prepared with the same method, okay, dengan cara yang sama, dengan kaedah dan ukuran yang sama, selalunya final readingnya sepatutnya akan dapat similar lah ataupun exactly the same. Tapi kalau kita made an error somewhere in the preparation, so the final result will be affected. So that's why kita prepare duplicate solution, so that we can observe any pattern that will help us in deducing whether we perform and whether we made an error somewhere in the preparation of those samples. Okay, so that is, where's the slide? So that is in a way how we control error in analysis. So that is the principle of quality control. That's why in QC we observe, kita kena faham the types of errors and what is accuracy and what is precision. So analytical methods ada dua jenis. Okay, there are two definitions, two categories of analytical methods. Okay, kamu buat test tu dekat dalam lab, ada dua jenis test. Satunya qualitative analysis, satu lagi adalah quantitative. So the key word in understanding the difference between qualitative and quantitative is this, the root word of this. So qualitative, the root word is quality, meaning we observe the quality of the species, the chemical species of the compound that we are testing. Kalau quantitative analysis, dia punya root word kat sini adalah quantity. So kita nak determine the quantity of the compound we are testing. So kalau kita perform assay test, meaning kita nak determine the amount of the API. Kita nak tahu exactly tablet Panadol 500 mg ni betul ataupun tak betul ada 500 mg dalam dia. So 500 mg tu meaning is the content, the amount of the API, iaitu paracetamol. So PCM is the compound that makes Panadol works as a painkiller. Okay, as a apa nama scientific term I forgot. Okay, dia untuk reduce swelling, reduce pain. So that is the purpose of Panadol. So what makes Panadol works as that adalah dia punya active ingredient, iaitu paracetamol. So quantitative analysis meaning kita nak determine exactly the amount, betul ataupun tak betul ada 500 mg dalam tu. So that is an example of quantitative analysis. Kita nak determine the quantity, the amount. Kalau qualitative analysis, kita observe, kita test the quality, the physical and the chemical quality and properties of that compound. Contohnya macam kita boleh determine PCM tu dia punya functional group adalah apa. Okay, so paracetamol, dia punya functional group, it contains two functional group. Dia mengandungi alkohol iaitu OH group, hydroxy group, dan juga amine, dia ada NH2 group. So dia tak determine how much amine, how much of the functional group, how much of the hydroxy group yang ada dalam paracetamol tu. Kita tak tahu how much. We only know that it is present. Ada OH group dan ada amine group. Ataupun kita nak ada certain ubat, kita perlu ada keperluan untuk kita kenal pasti bahan-bahan yang apa kita panggil impurities, bahan-bahan yang tidak sepatutnya ada tapi kita tak boleh nak separate from the substance. So kita set a limit. Katalah contohnya untuk ubat salbutamol respirator solution, only 25 ppm sahaja yang boleh ada dalam tu. So kita buat test, limit test kita panggil. Kita tak determine exactly how much katakanlah chloride, how much chloride is in salbutamol respirator group. Tapi kita tahu dia tak boleh lebih daripada 25. So we did this limit test, we perform this limit test, and in a way dia akan tunjuk a solution is more more keruh, more opalescent than the standard solution. So kalau lebih keruh, kita tahu the sample contains more chloride than 25 ppm. So we don't know exactly how much, but kita tahu dia lebih daripada limit. Okay, itu maksud qualitative analysis. And dekat bawah ni, if you go down this map, dekat bawah dia ada two other classification of analytical method. Kita ada classical methods and instrumental methods. Basically what it means, classical methods, we do not perform these methods menggunakan instruments, tak guna any machines, tak guna any heavy instrumentation. Okay, they just guna a set of apparatus macam glassware, a set of reagents and chemicals. So these are the examples of precipitation, extraction method, gravimetric and T3 Tapi kalau instrumental methods, dia ada specific instrument. Kalau nak perform conductivity, kena ada pH meter. Kalau nak perform spectrophotometry, kena ada kalau nak perform spectroscopy, kena ada spectrophotometer. Kalau nak perform chromatography, kena ada HPLC. Kena ada, HPLC is the instrument name. Kena ada gas chromatography, GC. Apa lagi? Kena ada UPLC, kena ada TLC. Okay, there are specific instrument kalau nak perform instrumental methods. Tapi kalau classical methods, we do not need any specific instrument. Itu perbezaannya. So dekat dalam ni there's a video. If you download the lecture note dalam bentuk PowerPoint, there's a video of example of classical methods dan juga instrumental methods. So classical method kat sini dia tunjuk extraction method, meaning dia nak extract a small compound from a drug. Contohnya kita nak extract, dalam video tu dia extract acetaminophen from aspirin. No, dia ada extract salicylic acid from aspirin. Ada satu tablet. Okay, this is a tablet of aspirin. Dalam aspirin ni dia punya API adalah salicylic acid. So kita boleh extract keluar salicylic acid daripada tablet ni. So, dalam video tu dia tunjuk macam mana nak extract. Basically dia akan powder this aspirin tablets, dia akan hancurkan, dia akan mix with a solvent. Tak silap saya dia akan, dalam video tu dia mix with hexane, I want to say hexane. So basically the purpose of this solvent adalah untuk separate salicylic acid ni from the rest of the other mixture. So dalam aspirin tablet ni ada banyak ingredient. Salicylic acid is one of it. So our objective here is untuk separate salicylic acid daripada the rest of the other mixture. So this is the purpose of this solvent hexane. Dia akan asingkan. Because of the properties of hexane, dia akan bind dengan salicylic acid. Dia tak akan bind with all the other ingredients. So dia akan dissolve only salicylic acid. So then kita akan filter. Bila dah asingkan salicylic acid from the rest of the other ingredients, kita akan keringkan, kita akan filter dan kita akan keringkan guna oven, and then we get a powder of salicylic acid sahaja. So that's what the video shows. But this is an example of classical method. Kita tidak ada specific instrument untuk perform this method. Berlainan dengan instrumental method. So dalam video ni saya tunjuk a person conducting spectroscopy. So dalam video ni dia tunjuk this big boxy instrument. This is the spectrophotometer, UV visible spectrophotometer. So there's a specific instrument. We only need to prepare the solution of the sample yang kita nak test. So bila dah prepare, we only need to masukkan the sample into this instrument, and the rest of the analysis will be performed by the instrument. Dia akan print out graph, dia akan keluarkan bacaan dekat dia punya screen dekat on this instrument. Okay, so if we don't have this instrument, kita tak boleh perform spectroscopy. Tapi kalau classical method ni, dia hanya perlukan just a set of apparatus. So as you can see from this slide, dia hanya perlukan beakers, conical flask, filter funnel, filter paper. So this is readily available and cheap. Every lab have this set of apparatus. Tapi not all labs ada spectrophotometer because it is very expensive and it only perform this specific task only. Glassware ni, conical flask ni boleh perform multitudes of analysis. So that is the difference between classical method dan juga instrumental method. Just remember, instrumental method perlukan a specific instrument. Okay, so going back to my question tadi, what is quality control? The gross answer is, the general answer yang saya bagi adalah it's just a method to control error in analysis. But if required to elaborate, how do we control the error in analysis? So dekat sini, I explain, we control error by monitoring the sampling process, the testing process, buat documentation and release procedure. This is to ensure that necessary and relevant tests are performed and the product is released only after we ascertain its quality. This is how we control error. Okay, bila kita buat kerja-kerja sampling, kita observe all the protocol. Kena pakai all the gowning, kena pakai face mask, kena pakai jumpsuit, kena guna the proper tool untuk sampling. Bila kita perform all the tests, to make sure all the measurements are accurate and precise. Bila kita report, bila kita buat documentation, kita report the actual data, and then bila kita after all that is done, baru boleh release to the market. So we observe all the flow of the process according to the protocols and guidelines. That is how we control error in analysis. Okay, control error bukan dekat dalam bahagian testing saja. It starts from daripada supplier lagi. So that's why kamu mesti faham the flow, the workflow. So it starts from the supplier. So the supplier must follow the guideline also. Supplier ni orang luar. Okay, so kilang akan order materials daripada supplier. So kalau supplier supply barang yang tidak berkualiti, dia akan affect the final product. Okay, so control error ni bukan sahaja terhad di QC sahaja. All relevant parties yang bekerja dengan QC, which means everyone lah, daripada supplier, warehouse, production, sampailah ke QA. Everyone must follow protocol. So that is how we control error in analysis, bukan dalam makmal sahaja. And this is the simplified role of QC. Ada tiga. Okay, so the first role of QC is to ensure products meet specific requirements. Kita ada a set of standards. I showed you a document hari itu. This is it. Saya besarkan sikit. So this is an STP. Kita buat STP ni, we develop STPs based on pharmacopoeia. Okay, so this is the set of tests yang perlu dibuat pada chlorpheniramine tablet. So kita mesti, this is the standard lah. Okay, the release limit. Kalau kita buat appearance test, all the tablets must be yellow, round, flat, bevel edge. Kalau kita perform assay test, the amount of chlorpheniramine malate must be at least 3.8 to 4.2 milligram. Okay, so kat sini dia tulis. So we base all of our tests on the standards from pharmacopoeia. So semua test mesti pass, mesti observe this specific specification. Second role is to identify products that do not meet that requirements. Maksudnya kalau ada yang fail, kita mesti separate, asingkan the segregation of the ones that meet requirements and the ones that do not. And then kita mesti investigate and kalau perlu kita halt production and monitor. Okay, so that is chapter 1. Okay, basically it's an introduction. That's why saya tunjuk kamu the workflow. I showed you a video also of the tour of the plant, macam mana vaksin Sinovac dibuat di Pharma Niaga. The purpose of that is so that you can see the insights, the working of how we produce certain pharmaceutical drugs. In that case adalah vaccine. Okay, kita need to adhere to certain guidelines, gowning procedure, kena pakai certain different gowns untuk different tasks. Dekat dalam QC lab pula ada different test kita kena buat, ada different instrument, and then dia tunjuk macam mana different departments work together. Okay, so that is the introduction of instrumentation analysis. Okay, so in order to discuss our first tutorial, saya habiskan dulu this ni. So sekarang saya nak go over the tutorial. This is the one yang saya like. Okay, tak ada orang jawab lagi ya. My bad. Okay. Wait a minute. Saya nak ambil yang from a previous class. Saya dah padam. Wait a minute. 15. Okay, so kita pinjam cohort 15 Penang punya submission. Okay, so tutorial number 1 basically they go over what we've gone through lah. Okay, so basically it starts from the video that we watched until the final slide of the lecture note. So question number 1 kat sini saya tanya, quality control is a procedure and guidelines to ensure the manufactured products are up to standard. So the answer is true kat sini. QC has a system that includes a procedure and guidelines. Macam mana kita nak operate, macam mana kita nak perform test, apa tu lagi, macam mana, what do we need to wear dalam lab, what is the safety procedure, safety protocol, because those things akan affect the quality of the testing also. Okay, so dia bukan hanya test semata-mata. Cara kita buat kerja pun is also part of quality control. Is a system. So quality control is a procedure and guidelines to ensure the manufactured products are up to standard. Jawapannya true. Question number 2, choose the correct components of QC. Basically maksud saya kat sini apakah teras-teras, maksudnya QC ni basically buat apa. Okay, so choose the correct components meaning QC exactly buat apa. So the answer is all of them. Dia buat sampling, meaning dia kena sediakan SOP macam mana nak buat sampling. So I say that because kerja-kerja sampling dibuat oleh warehouse personnel, because supplier akan hantar barang dan barang akan diterima oleh warehouse. So warehouse personnel akan simpan dalam warehouse. So dia akan buat sampling, maksudnya dia akan take a small portion. So kalau barang yang datang tu, the material, contohnya the API of atenolol, kita order 200 kg. So kita tak akan bagi 200 kg sekaligus. Untuk bulan ni batch nombor 1 kita ambil only 1 kilo. So kita sample out, we take a small portion from the whole batch of 100 kg tadi tu. So kita take 1 kilo untuk production for the first batch atenolol untuk bulan March. So dia bagi pada production akan buatlah formulation buat ubat atenolol batch nombor 1 bulan March. So the rest, baki lagi 99 kg tu dia simpan dalam warehouse. Tutup rapat-rapat, seal, simpan dalam dia punya shelf properly, label and tag. Okay, itu maksud sampling. So walaupun sampling dibuat oleh warehouse personnel, tapi all the SOP disediakan oleh QC, because barang-barang bahan tersebut adalah raw material yang akan ditest dan dimonitor oleh QC lab di bawah management of QC lab. Tapi stored is by warehouse. That is specification. Specification maksudnya kita tetapkan kaedah nak test. Kalau nak perform test, assay test untuk fluorphenylamine, kita nak buat kaedah apa? Kita nak buat guna titration ke, nak buat chromatography ke, spectroscopy ke. So QC manager lah basically, dia akan pilih test apa yang sesuai dengan the resources that we have. So kalau lab tu tidak ada spectrophotometer, so kita perlulah buat test yang lain, titration for example. Tak boleh buat assay test guna spectrophotometer sebab kita tak ada spectrophotometer. So kita buat kaedah titration. So dia akan setkan, dia akan sediakan this document. Dia akan sediakan dokumen ni. So QC manager and team dia lah. So dia akan pilih, okay, macam mana nak buat appearance test, macam mana nak buat identification test, macam mana nak buat dissolution test, and so on. Okay, ini tugas QC. Set specification, set the standard. Hey, where was I just now? Sini. Testing ni memang 100% QC lab, tak ada orang yang buat. So the actual analysis and testing are performed by QC. And lastly, documentation. So bila dah buat all these things, sampling, specification and testing ni kena ada documentation lah, kena ada black and white. So kalau buat sampling kena sediakan SOP. So bagi one copy to warehouse so that they can refer and simpan satu dekat dalam QC lab. Specification and testing, this document lah. This is the document. Sediakan dokumen ni so that QC personnel boleh guna masa dia pernah perform the test. And documentation also means includes report. Bila dah perform test, kita perlu write the report. Okay, assay test berapa miligram, kita dah identify based on the test. Apa lagi? Dissolution test, what is the result? Related substances test, what is it? Limit test, what is it? Write down the report. Okay, all of these are the components of quality control. Next question, choose the correct reason why an analytical weighing balance is best to be placed on a marble working bench. So this question refers to a video that I showed. So this is, silap saya lah, saya tak edit. So from a previous cohort, saya ada attach a video dalam Google Classroom so that they can watch. So dalam video tu dia tunjuklah the proper way of setting certain lab instruments. So for example, untuk weighing balance, it is best to place them on a marble working bench. The idea is, the objective is to minimize vibration. Tak nak ada sebarang getaran. Kalau meja kayu, meja plastik, meja besi, dia macam less dense, ringan, dia mudah terkesan from movements. Kalau orang lalu berjalan, dia akan ada vibration. So vibration akan affect the reading of the measurement, timbangan kita. So kita tak nak ada anything that could easily affect our weighing. So that's why it is best to place a weighing balance on a marble working bench. Dalam soalan next question, it is not recommended to use weighing balance near a door, window ataupun air vents because it can be affected by air current, angin lah basically. So kalau kita buat kerja-kerja timbangan, kalau kamu ada powder of a sample yang kamu nak test, kamu kena timbang. Timbang pula bukan dalam measurement yang besar. Contohnya macam 10 mg, very small. Just a small powder on a small spatula. So kalau kamu just dah angkat that one small spatula nak masukkan dalam weighing balance tu, suddenly somebody opens the door next to you and dia tertiup. So kamu maybe tertumpah sedikit, kamu dah ambil bacaan 10 mg, tapi after kamu angkat nak masukkan dalam glassware, somebody opens the door and the air just move and it blows the powder that you just weighed. And kamu tak perasan, and kamu masukkan dalam kamu punya glassware and you proceed with preparation. So your dilution and your final result will not be accurate. That can affect your final reading. So we do not want any of that affecting our analysis. The following are the roles of QC except. So roles of QC ada 3 based on the lecture note yang kita dah tengok tadi. Kita test the product, kita identify non-conforming product, and isolate and investigate. So what QC does not do adalah approve products for sale. Itu adalah tugas QA, quality assurance. Next question. This is to introduce you guys to some of the instruments, okay, the routine instruments yang kita selalu guna. So item number 1, this is called a burette. We use this to perform volumetric analysis ataupun titration. It's just a long glass rod. Dia ada segregation, dia ada graduation kat sini. Depending on how big the rod is, usually it's 25 and 50. So the measurement of burette starts kosong dekat atas. And kalau dia 50 ml, 50 dekat bawah. Okay, it's different than a measuring cylinder. Kosong dekat bawah and the top number dekat atas. So this is a burette. Item number 2 is a conical flask. We use this untuk mix solutions. So that answers the next question. Choose the correct reason why item number 2 has a narrow neck. This is the neck, narrow. So this is why it looks like a cone. Dia lebar dekat bawah, and as it goes up, dia jadi semakin tirus, and here it is straight up. So why it has a narrow neck? Because it is to avoid spilling when mixing chemical solutions. So we use conical flask untuk mix solutions. So bila kita mix solutions, kita boleh kita dah masukkan 2 solutions dalam conical flask, we can just swirl. Kita boleh swirl, kita boleh just goyangkan. Tak perlu guna spatula ataupun stirring rod untuk kacau macam kita bancuh air. No need of that, because it is designed so that we can just swirl it around, goyangkan untuk mix the 2 solutions together. That's why dia ada narrow neck. Kalau kita swirl, kalau kita goncangkan, kalau kita goyangkan dia, kalau dalam beaker for example, mudah untuk tertumpah. So this one has a narrow neck, so it is impossible for the solution inside to spill. Item number 3. So these are the items yang kamu akan guna, yang kamu akan get familiar with bila kamu masuk dalam practical class nanti mulai 28 hari bulan. So item number 3, this is known as a pipette bulb ataupun pipette filler bulb. Jawapannya betul, tapi saya dah set answer jawapannya macam ni, so dah salah. Okay, so jawapan ini pun betul. Dia adalah sejenis bulb untuk kita guna pipette. So what is a pipette? This is a pipette. Item number 4. We use pipette untuk take accurate measurements of volume measurements of solutions. So kalau kita nak, if it requires for us to measure 1 milliliter of solution, there is a 1 milliliter pipette. So dekat belah kiri ni, this is the smallest lah, 1 milliliter pipette. So kita boleh measure 1 milliliter pipette using this specific item. Kalau kita nak measure any other measurement, there are other type of pipette. Kita ada starts the smallest yang saya pernah guna adalah 1 milliliter, 2 milliliter, 3 milliliter, 5, 10, 15, 20, 25, 50. Okay, so the reason why pipette is designed so that how we use the pipette and how the punya graduation works, it is more accurate than using measuring cylinder. So kalau kamu nak take a 5 milliliter measurement of a solution, it is best that you use a pipette. Jangan guna measuring cylinder. Okay, the smaller the measurement, the more likely it is for us to make any error. So pipette reduce the risk of us making that error. So that's why it is the most accurate item untuk take small measurements of solutions. So dalam makmal kita akan attach this bulb dekat the top of this pipette. So kita akan sedut lah, kita akan picit this balloon here yang bulat ni, kita akan sedut solution into this pipette by pressing on this bulb belum dekat atas ni. So kalau nak keluarkan pun there's a spot here that we can press, that akan keluarkan solution from the pipette into our flask ataupun our beaker. Item number 5, this is known as a volumetric flask. We use volumetric flask untuk prepare a specific concentration of solution. Okay, so kalau contohnya kita nak prepare 1 molar of sodium hydroxide solution, so kita perlu sediakan that solution in a specific volume. So kalau kamu nak sediakan 250 ml of 1 molar sodium hydroxide solution, kamu akan sediakan that solution dalam volumetric flask, because a volumetric flask measures specific volume sahaja. So in this case, dalam item number 5 ni, saya attach a picture of 250 milliliter volumetric flask. So this specific glassware only measure 250 ml sahaja. Dia hanya ada satu senggatan dekat this neck here, just one line. So if you prepare a solution sampai that line, you know you have 250 milliliter of solution. Next question. Blank personnel will accept and inspect any incoming materials at a manufacturing plant. The answer is warehouse. So any material baru sampai dekat manufacturing plant, warehouse yang akan inspect. Dia akan terima dan dia akan simpan dalam warehouse. Sampling procedure will be performed by warehouse personnel for distribution and dispensing to production and QC department. So, macam saya cerita tadi, jawapannya adalah betul. Okay, walaupun sampling falls under the scope of QC, tapi yang akan buat kerja-kerja sampling itu adalah warehouse. Next question, choose the correct reason why a personnel must wear PPE, personal protective equipment, such as gown, goggles, gloves, and shoe cover while performing sampling procedure. So the idea is to avoid cross-contamination. Cross-contamination meaning kalau kita perform any task, there's two things involved, you and the material. So this material could affect your health, and you could affect the quality of the material. So if you do not wear any mask, for example, and you breathe in to the material, you breathe in this material, kamu tersedut material ini, that material could affect your lungs. Okay, so that is the contamination that we do not want. Contamination. We do not want that. But you also could contaminate the material. So kalau kamu tak pakai glove, tangan kamu kotor, you handle the material, you could contaminate the material. So we do not want that also. So both things could affect each other. This is called cross-contamination. So the idea why we wear PPE is to avoid cross-contamination. The same lah macam kita pakai topeng, kita pakai topeng lah. I'm directly translated in my head. Kita pakai face mask right now. Okay, kita tak mau contaminate others, and we do not want others to contaminate us with the virus. Okay, same principle, same thing. Next question, choose the correct name for a reference book that contains specific formulation, description and testing procedures for wide varieties of drugs. So jawapannya adalah pharmacopoeia. British pharmacopoeia pun betul lah. It is more specific. So what is pharmacopoeia? I didn't put that in my lecture note. So if you just allow me to. Pharmacopoeia is basically a journal. It's a collection, a publication of all the registered drugs of that certain area. So for example, United States ada pharmacopoeia dia sendiri. Maksudnya all the drugs registered by FDA and FDA kan monitor Food and Drugs Service. So all the drugs registered in the US semuanya disenaraikan dalam pharmacopoeia ni. So what else ada dalam pharmacopoeia ni adalah all the details. Contohnya kalau ubat tu amoxicillin, antibiotic tablets didaftarkan dalam negara US, okay, and all the details of amoxicillin tablet akan ada dalam pharmacopoeia, meaning dia punya nama, dia punya apa nama, chemical compound punya nama, dia punya molecular weight, dia punya physical and chemical properties, macam mana nak bancuh ubat tu, macam mana nak perform all the methods to perform tests on the drugs. Okay, semuanya tersenarai dalam pharmacopoeia. So this is what it means bila dia kata it is an official publication containing list of medicinal drugs with the effects and directions for the use. So kalau kamu pernah tengok leaflet, kalau kamu beli ubat, kamu akan dapat satu leaflet. So kat situ dia senaraikan juga the pharmacokinetics, the pharmacology. So all of that terdapat from pharmacopoeia. So this is basically a book lah. Kalau kamu tak pernah tengok, dia macam it's a big encyclopedia like this. It has many volumes, considering there are lots of registered drugs already. So the big ones, the big pharmacopoeias adalah US pharmacopoeia, British pharmacopoeia, Japanese, Indian, European pharmacopoeia. These are the 5 yang saya pernah guna lah masa saya kerja dulu. In the big ones. Selalunya negara-negara yang besar ataupun negara yang dah lama establish dia punya pharmaceutical manufacturing industry, dia ada big pharmacopoeia. Malaysia tidak ada pharmacopoeia. So that's why kita refer to this. Any of this can do. Okay, next is a set of questions about accuracy and precision. So Fatima is the pharmaceutical analyst, performs 3 assay tests on PCM tablets. So this is to determine the amount of the API. The goal is to get 100% lah. Okay, so the results yang dia dapat adalah 99%. The second duplicate dia dapat 100, and the third one is 101%. So my question is, are her results accurate? Jawapannya adalah yes. So dalam Fatimah ni, they perform 3 duplicates, 1, 2, and 3. The first one dia dapat 99%, 100%, and the third is 101. So the goal is 100%. So my question is, are her results accurate? Betul tak accurate kan? So jawapannya adalah betul. Yes, her results are accurate because the definition of accuracy is the ability of a person ataupun an instrument to measure a certain to measure a certain measurement closest to the standard value. Sorry, I beg your pardon. Okay, so for the first measurement dia dapat 99%, which is close to the standard value. The second measurement dia dapat 100%, so bullseye. The third one also dia dapat close to the standard value. So if you are able to perform a measurement close to the standard value, that means you are accurate. Next question. Here, sorry, wrong mouse. Next question. Kamala, a pharmaceutical analyst, performed 3 assay tests juga on chlorpheniramine tablets. The goal is still 100%, and her results are 92%, 106%, and 95%. My question is, are her results precise? So dia dapat kat sini 92. So Kamala, 3 duplicate. The goal is 100%. 1, 2, and 3. 96. 92, 106, 95. 92, 106, 95. So my question is, are her results precise? So the definition of precision adalah the ability of a person ataupun an instrument to measure the same value again and again. Itu maksud precision, kejituan. Dia boleh ukur the same ukuran again and again. So kat sini basically dia prepare 3 solution of the same solution. So ini solution yang sama ketiga-tiga ni, tapi if you look at the results yang dia dapat berlainan, 92, 106 and 95. So Kamala here ataupun the instrument that she used are not able to make the same measurement again and again because dia punya bacaan berterabur. So Kamala is not precise. And last one, based on the previous question, choose the type of error that is best describe Kamala's analysis. So tengok balik dekat dia punya result. So my question is, from this reading 92, 106 and 95, what do you think is the type of error that she made? So kita tengok dia punya, disebabkan dia punya reading is berterabur 92, 106 and 95. The goal is 100. Okay. So dia tak dapat 100 pun, and also dia tak dapat repeat the same results again and again. So must be dia buat some sort of random error because they are basically, it boils down to either systematic error ataupun random error. So if we perform systematic error, it means that we made an error. Kalau kita buat 3 duplicate solution, we repeat the error 3 times. So katakanlah in the preparation of this assay test, Kamala was supposed to measure 10 milligram of chlorpheniramine, but instead she measures 9 milligram. So untuk first solution, they measure 9 milligram. The second, she also measures 9 milligram. The third one also 9 milligram. So dia tak measure 10, instead they measure 9. So this is a systematic error. Dia ulang kesalahan yang sama berkali-kali. That's why dia punya kata systematic kat sini. Okay, but if she perform a random error, then her final results punya taburan will be random also. Just like this lah, 92, 106 and 95. So maybe instead of 10 milligram, maybe kat sini the first one they measure 9. The second one maybe the measure terlebih, maybe 13 milligram. The third one maybe 9.3 milligram. Okay, so ada sebab lah kenapa error ni boleh terjadi. Okay, so kita kena tengok balik. Maybe it's Kamala, maybe it's the weighing balance that she uses. But ultimately, saya nak kamu nampak kat sini how to see the pattern. Okay, kalau dia berterabur macam ni, most likely dia akan perform random error. Tapi kalau dia, contohnya lah Kamala dapat 92% in the first one, the second one also 92%, the third one also 92%. So our goal is to get 100, but Kamala get 92 for all her duplicate solution. So that means it is most likely she made a systematic error. Okay, this is the best example that I think best describe the difference between accuracy and precision. Okay, so that's it untuk tutorial number 1. And that's it also lah untuk chapter 1. So let's take 5. Kita akan continue mana ni? Kita akan continue with chapter 2 bila kita finish with our break. Okay, so 5 minutes lah. 10:05 kita mula balik.
Assay of citric acid, titration. First weigh your citric acid anhydrous, 1 gram. So we're going to perform duplicates. So use 3 conical flasks and weigh 1 gram for each of the conical flasks. Place the weighing disc carefully, gently putting in the samples. Record your weight and fill it in the conical flask. Dissolve the samples with distilled water, 20 ml. Make sure all are dissolved. And then prepare your burette with your sodium hydroxide standard solution, 1 molar, and then put in a few drops of phenolphthalein indicator solution. Now you begin titrate, carefully swirling as you control the burette until the color changes to light pink. Stop titrating and record the value of the standard solution. So repeat the titration with all your duplicates and make sure all of them are faint pink in color. So as you can see, this is what we want. A very faint pink, light pink, not too bright. After you've attained everything, calculate your amount and your purity.
Okay semua, I'm back. Sorry lambat sikit. Alright, so Humaira Azwar. Selamat datang Humaira. Cukup 40 orang. Another one. 9 orang tak ada. Okay, so right now kita akan go into a brief introduction on chapter 2. So chapter 2 tajuknya adalah volumetric analysis. So before kita go over the introduction, I want to show you this video.
Assay of citric acid, titration. First weigh your citric acid anhydrous, 1 gram. So we're going to perform duplicates. So use 3 conical flasks and weigh 1 gram for each of the conical flasks. Place the weighing disc carefully, gently putting in the samples. Record your weight and fill it in the conical flask. Dissolve the samples with distilled water, 20 ml. Make sure all are dissolved. And then prepare your burette with your sodium hydroxide standard solution, 1 molar. And then put in a few drops of phenolphthalein indicator solution. Now you begin titrate, carefully swirling as you control the burette until the color changes to light pink. Stop titrating and record the value of the standard solution. So repeat the titration with all your duplicates and make sure all of them are faintly pink in color. So as you can see, this is what we want, a very faint pink, light pink, and all dissolved. After you've obtained everything, calculate your amount and your purity.
Okay, so that is how we perform titration. So this is what you will be performing. Ini yang kamu akan buatlah dalam kelas partikel nanti. So why do I show you that video first? Is so that you understand at least kamu nampak what is exactly is volumetric flux. Dia bukan just one thing. Okay, there are a series of steps, a series of procedure macam mana nak perform volumetric analysis. So titration is a type of volumetric analysis. So volumetric analysis is a type of quantitative analysis, meaning kita nak determine, kita nak tentukan the concentration of a known reactant. So before we move from this, saya nak kamu tahu dulu, kalau kamu terlupa, what is a concentration? Okay, so a concentration basically, cara kita, a concentration is how much solute is dissolved in a solution. So kalau kamu ada 1 glass of water. Okay, so this is water. Kemudian kamu masukkan katakanlah 1 sudu sugar, 1 tablespoon. 1 tablespoon of sugar. So that means bila kamu kacau, bila semua gula, when all of the sugar are dissolved in this water, you will now have a solution, a sugar solution. So asalnya ini hanyalah H2O, water. So bila kamu dah campurkan 1 tablespoon of sugar into the water, now you have a sugar solution. Sugar solution. It is not water anymore. Kerana dalam air itu sudah terlarut, sudah ada sebatian gula dalamnya. Okay, gula yang kita campur tadi itu dah larut. It is mixed. It is a homogeneous mixture, dah terlarut sebati dengan water molecules. So that's why it affects dia punya taste. Pada asalnya water tidak ada rasa manis. Bila kita campur 1 tablespoon of sugar, dia ada rasa sedikit manis. So inside this sugar solution, there is an amount, a certain amount of sugar yang sudah larut. So kalau kita nak express the concentration, kalau kita nak I always stumble in the Malay translation. Kalau kita nak katakan, kalau kita nak tunjukkan how much, berapa banyak gula yang terlarut dalam tu, ada beberapa kaedah in chemistry. Okay, so in chemistry there are several ways for us to express. Kalau macam contohnya kalau berat kamu boleh express your berat in multiple units. Kamu boleh kata berat kamu in kilogram, in gram. Kamu boleh guna dalam bentuk stones, unit stones. Okay, so sama juga dengan concentration, kita boleh terangkan, kita boleh jelaskan how much sugar is dissolved in this water menggunakan several units. So for example, in our syllabus kita guna 3. Kita ada molarity, kita ada molality, dan juga kita ada normality. So the unit untuk molarity adalah capital M, M besar. Molality M kecil, normality M besar. So ada perbezaannya lah. Tapi basically dia express how much sugar is dissolved in this water. Okay, so for example, in molarity, they express in how many moles of sugar dissolved in that liter of water. So katakanlah 1 tablespoon of sugar ni is 0.5 mole. For example, for the sake of this demonstration. And ini kita ada 1 liter of water. So kalau kita nak express the concentration of sugar yang larut dalam air tu, kita boleh bahagikan 0.5. Saya bagi 0.5 ke 1? Saya sendiri 1 lah. 0.5 mol bahagi dengan 1 liter. So the molarity of that sugar solution adalah 0.5 molar. Itu cara kita express. Okay, so basically concentration is the amount of solute dissolved in solution. So kat sini basically there are 3 parts of a solution. Kita ada solute. We have a solute, and then we have a solvent, and then these two will make a solution. So dalam contoh saya tadi itu, the solute adalah sugar. The solvent is H2O, air. So bila gula ni terlarut dalam air, kita akan dapat air gula, sugar solution. Okay, so if we want to say increase the concentration, kalau kita nak bagi air tu lebih manis lagi, so what we can do adalah we add another tablespoon of sugar. 1 tablespoon of sugar. So if we increase the amount of solute, the concentration will increase. Okay, because the concentration is defined by the amount of solute yang terlarut, the amount of solute that is dissolved in the solution. So if we add more sugar, more tablespoon of sugar inside this 1 liter of water, the concentration of the solution will increase, meaning tadi 0.5 mol saja. So kalau kita dah tambah another tablespoon, meaning kita dah tambah another 0.5. So now we have 1.0 mole of sugar divided by 1 liter. So now the concentration has been increased to 1.0 molar. Okay, so if you add another tablespoon, now we have 1.5 mole of sugar divided by 1 liter. So the concentration is now 1.5 molar. If you add another 1 tablespoon of sugar, now ditambah lagi 0.5, dia jadi 2.0 mol. divide by still 1 liter. Kita tak tambah any air. So now the molarity is 2.0 molar. Okay, so that is concentration. So in the sense of ubat, pharmaceutical drug, we are talking about the content lah, the dose of the ubat. So contohnya macam certain drug, dia ada label chlorpheniramine tablet 4 milligrams, glycoside tablet 4 milligrams, paracetamol tablet 500 milligram, ada 650 milligram, vitamin C ada 500 milligram, ada 1000 milligram. Okay, those are the concentration of the API yang ada dalam tablet tu. Okay, so kalau macam Panadol, dia ada 500 milligram dalam satu tablet. Ada juga Panadol 650 mg, meaning the punya concentration is now increased. The content of the API tambah sebanyak 150 mg. Macam vitamin C, macam dalam example saya bagi tadi, dia ada 500 dan juga 1000. So the different concentration depending on how much the solute is. So the purpose of volumetric analysis dalam video tadi tu, the titration, kita nak determine the amount, the concentration of the reactant. Okay, so kita boleh guna titration untuk determine the content of, kalau kita test Panadol tablet, we can determine the content of the API, the paracetamol. Kalau kita test vitamin C tablet, kita boleh determine how much ascorbic acid is in vitamin C tablet. Okay, so this is known as titration, in which a substance of known concentration and volume is used to react with another substance of unknown concentration. So basically kat sini, let me go to my whiteboard. If you saw the video tadi, bila kita perform titration, we need two solutions. And better I just show the video again because I look at where is it? Okay. So dalam video ni, it's just a short video. Saya nak cari the point where dia buat titration. Okay, so kat dalam video ni, dia prepare in the beginning. Let me mute. Okay, in the beginning, the timbang 1 gram of citric acid in this case. So this is to prepare the sample solution. So this sample solution, kita nak determine the amount of citric acid yang ada dalam 1 gram sample tadi tu. Okay, so kat sini the kaca bagi everything dissolve. So this is the first solution, our sample solution. And then, bila dah siap tu, kita akan prepare another solution, masukkan dalam burette. So this is our standard solution. Okay, so our standard solution, kat sini saya tulis fill in the burette with 1 molar, 1 m NaOH standard solution. Okay, so NaOH is our second solution. It is known as a standard solution. Why is it known as a standard solution? Because we know its concentration. For a solution to be a standard solution, the minimum requirement is kita mesti tahu dia punya concentration. So in this case, dalam video ni kita guna 1 molar sodium hydroxide solution. So the how it works is kita akan titrate. So what titrate basically means, kita akan biarkan these two solution mix and react together. So as you can pause please. So as you can see dalam video ni, burette is attached to this retort stand. Dalam burette ni ada sodium hydroxide standard solution. Dekat bawah ni ada conical flask. Dalam conical flask ni ada citric acid solution. Okay, so you remember when we perform titration, kita nak determine the concentration of our sample solution, of our titrate. So solution dalam conical flask kat bawah ni is our titrate. This is our sample solution. Okay, so kita nak determine the molarity of this solution kat bawah ni. Solution kat atas ni is our standard solution. Kita dah tahu dah concentration berapa, 1 molar. So the idea is, the principle is, when these two solution are mixed dalam conical flask kat bawah ni, dia akan make the color of the solution dekat bawah ni change because kita dah campur satu indicator solution. Kita akan get more in detail of what those things are later. Okay, but now, for now, just understand, when these two are reacted, dia akan, something will happen in a way that it will make the color of the solution dekat bawah ni change. So when the color is changed, that is an indicator for us to stop titrating, stop mixing the two solutions together. So we take a reading of the burette. How much sodium hydroxide solution is used until the color is changed to pink. So bila kita ada volume dekat pada burette tu, kita boleh guna that data untuk calculation. So that is how from the formula kita boleh determine the concentration of the citric acid solution yang ada dalam conical flask. Okay, so itu yang dia maksudkan. Macam mana nak tutup? Go away please. Okay, itu yang dia maksudkan bila dia kata known as titration in which a substance of known concentration. A substance of known concentration ni is our standard solution. Kita tahu concentration dia 1 molar. Is used to react with another substance of unknown concentration. So this is our citric acid solution yang dekat dalam conical flask tu. Kita tak tahu concentration dia berapa. So kita titrate dia dengan our standard solution yang kita tahu concentration dia adalah 1 molar. So dekat dalam ni ada another video also, saya attach a different video. Kamu boleh tengok video ni, basically the same macam tadi tu. Okay, dia tunjuk macam mana nak perform titration. So how does it work? Dalam video yang saya tunjuk dia tunjuk step by step lah. So this is the explanation from that video. So dalam video tu dia tunjuk substance of known concentration adalah sodium hydroxide juga. Dia guna 0.1002 molar. The substance of unknown concentration adalah sulfuric acid, H2SO4. So bila dia perform titration, the final reading bila color dah tukar jadi pink, the final reading is 9.57 milliliter. So bila dia titrate tu dalam video tu, the color has changed, the stop titrate, dia tengok bacaan pada burette is 9.57 milliliter. So they take the reading down, record. And the volume of the sulfuric acid adalah 10 milliliter. This is how much we prepared. Kita measure everything. So we will use this data, these values in our titration equation, iaitu M1V1 equals to M2V2. So this titration equation basically dia akan kira the molarity of our sulfuric acid tadi tu. So M kat sini it stands for molarity, which is concentration lah. V is for volume. So M1V1 is the values for our our standard solution. So molarity M1 is for inilah mana dia tadi 0.1002 molar. V1 kita dapat from our titration 9.57 milliliter. So you key this in M1 and V1. Equals to M2V2. So M2 is the molarity of our sulfuric acid. Ini unknown concentration kita nak cari. And then V2 is the volume of the sulfuric acid yang kita guna, iaitu 10 milliliter. So you key these values in this titration equation. Jadikan M2 as our unknown. So kita akan dapat macam ni lah. Oh, saya silap type kat sini. 0.1002 molar. Darab dengan 9.57 bagi dengan 10. So the answer is bagi dengan 10 kat sini. So the answer is 0.09 589. Okay, sini saya typo kat sini, sepatutnya 0.1002. So our final answer bagi dengan 10, 0.09589. So the molarity of sulfuric acid adalah 0.09589 molar. So this is how we determine concentration using titration, using volumetric analysis. So this is basically in a general sense what is volumetric analysis. Okay, so I'd like to stop here first so that you can marinate on that. Tapi saya nak kamu ni lah tengok video ni dulu. This is a step by step video, a thorough video yang daripada video yang saya prepare, saya tunjuk tadi tu. Okay, maybe you can check that video with the ones yang saya tulis kat sini so that you get the idea better. Okay, so dalam next class kita akan discuss tutorial number 2. And as we discuss, saya akan elaborate lah all the other points macam kita buat tadi. Dia akan cover the whole chapter 2. Okay, any questions? Tak ada questions tentang tulis? Okay, so ada any other question tentang return to campus ataupun tentang retail pharmacy? Okay, kalau ada yang masuk lambat tadi, saya ada mention there are a couple of students already, like close to 10, cakap tak dapat any placement, banyak orang reject sebab because of COVID. So later today saya akan bagi satu maybe a Google form. I need your ni lah saya perlu tahu siapa dan location kamu for us to help you get a placement somewhere. Okay, but the catch is maybe the attachment maybe not be close to where you live lah. Okay, so that could be the case lah, the problem. Kita ada about 2 weeks lagi before kamu start, so hopefully kita boleh dapatkan everyone placement. Okay, but for now macam ada some of you yang tengah quarantine sebab ada symptom. Tapi try to look kalau kamu okay lah. Okay, if it's too much, just rest. Tapi kalau kamu boleh, just look for placement online. Okay, use email. Okay, so make sure kamu attach the email with the booklet dan juga with the official letter and the permission letter yang saya sediakan. Okay, kalau kamu macam tak berterabur sikit, saya ada buat this homeroom Google Classroom untuk C38 lah, untuk cohort kamu. So dalam this Google Classroom saya ada attach all the materials or the related document. Kalau kamu macam tak organize, susah nak dapatkan from WhatsApp, dalam ni ada. So kalau kalau kamu nak dapatkan access ni, maybe saya akan share this link lah later on. Saya guna ni untuk saya punya management saja, for my benefit lah. Tapi kalau kamu nak, maybe saya akan share the invite later. Kamu bolehlah join kalau kamu nak. Okay, dalam ni saya dah all the material macam master plan, name list, technical support. Kalau macam ada email problem, kamu boleh dapatkan siapa nak contact kat sini. Kalau macam kamu student affairs, okay, saya dah masukkan address of the I forgot to attach. Apa lagi? Academic calendar. Kalau macam kamu nak withdraw EPF untuk bayaran, fee and payment inquiry, nak contact siapa, semua ada kat sini. So kalau kamu interested, saya akan invite. Kamu boleh ni lah keep track of the documents, official documents yang kamu boleh dapatkan, download kat sini, senang. WhatsApp maybe berterabur kan, sometimes kalau kamu tak download, dokumen tu dah tak ada dalam phone kamu, hilang. So kamu kena cari balik. So kalau dah ada kat sini, senang. Sebab saya pun keep track dekat sini. So if you are interested, saya akan share the link now. How to people. So kamu boleh join kalau kamu nak. Where's the chat room? So saya akan attach the chat room. Kamu boleh join kalau kamu nak, if you want to keep track. Where is it? Okay, so the link is in the chat room. Kamu boleh join kalau kamu nak. Okay, so kalau tak ada apa-apa, terima kasih, itu saja. Thank you for joining. Don't forget, nanti saya akan publish tutorial number 2. Jangan lupa buat. Next class kita akan discuss. Thank you all. You are dismissed. Stay safe. Thank you.
Thank you, sir.
Thank you. Let me stop recording.
Thank you, sir.
Thank you.